I think I'll get started here. Thanks to all of you who are attending this session. I know you have many choices, so really excited to be here presenting to the Hadoop community on this topic of self-service provisioning and Hadoop management with Apache Ambari. So just to be super clear, when we talk about self-service Hadoop, the self-service Hadoop has been there for a long time, especially on Amazon or Azure HD Insight. You can go provision Hadoop clusters in the public cloud. But what we're talking about here today is providing a self-service experience on premises in your data center using your existing physical infrastructure versus talking about how we provision Hadoop clusters in a public cloud-like environment. Just a quick introduction about myself. I'm a product manager at Blue Data. And Blue Data is an infrastructure software company. We provide an infrastructure software that allows you to create an Amazon EMR-like experience on premises, as well as some other capabilities that you can learn about at our booth. I don't want to bore you with that. Prior to Blue Data, I was at Pivotal, a spin-off from EMC, and prior to that at Greenplum. I was responsible for all of the Hadoop and data lake related products like Pivotal HD and Hawk and Gemfire XD and such. I actually am infamously, I guess, famous for championing Ambari at Pivotal early last year. To really based on some of the experiences I had personally with Ambari and some of the progress I saw since version 1.5. And then prior to that, I've been in a BI analytics many roles, but I introduced Hadoop at a company called Merced Systems that is now Nice Systems around customer experience analytics. On a personal front, I'm a soccer dad, and I actually have to rush to my son's soccer practice after this session. I'm a big sports fan as well. It's a tryout season right now in soccer. So in terms of the agenda for this talk, I have a very simple agenda. First and foremost, want to spend a little bit of time defining self-service Hadoop. What it is, why is it important, and how it can fundamentally change the consumption model and adoption of big data. I'm a big believer in Hadoop and fundamentally believe that there is an opportunity to do more in this area of self-service that will broaden the adoption for big data. Then we'll talk a little bit about the building blocks of self-service Hadoop. We'll drill into each one of these in a little bit more detail. And then talk about how Apache Ambari fits in. And talk a little bit more about what we've done in terms of integrations with Apache Ambari to enable the self-service experience. And then give you a live demo of the product, if the demo gods are with me. So we'll do that. And then we'll leave about 5 minutes or so, or maybe 10 minutes, hopefully, for Q&A. So before I start, how many folks in this room administer a Hadoop cluster today? Show of hands. That's fantastic. OK. And how many of you are actual end users of Hadoop? In other words, you're a business analyst or a self-proclaimed data scientist or data analyst. How many of you are that type? All right. Small group, but at least we have a few show of hands. So hopefully we can get some questions from both the teams. So let me go into just sort of set up why self-service, what is important, why is it important, and so on. There's been a lot of analyst reports in the last few weeks, especially, showing kind of the signs of and telling the story of Hadoop. Is it a glass half empty or half full? They're optimists, they're pessimists. There's a back and forth debate, especially in the analyst community, on whether Hadoop really has the potential or we're just wasting our time. And I fundamentally believe that there are probably there's probably some truth to both sides of the argument. look, Hadoop is very complex. It is a collection of products, as you all know, and it is super complex, and the adoption rate, if you just look at the total number of enterprise customers across the board, they're order of magnitude smaller than what you have in the RDBMS world. And I think the couple of reasons that are cited that you see on the slide up here, first one is around skills and capabilities, which is true to the extent, and if you double click onto it, is the skills and capabilities involved with deploying a cluster, which involves tens of thousands of clicks where you have to get your physical servers. And again, I'm talking in the context of on-premises Hadoop. You get your physical machines, virtual machines, what have you. You have to deploy the software on it, get the software, deploy it, configure it, and so on and so forth. And that is challenging, and you need a lot of training for that. But I think that's something that absolutely can be solved for, right, with training and other things that are happening in the community. The second one is around determining how to get value from Hadoop. And this is an important one. When you say value from Hadoop, we're talking about data scientists, business users, being able to get access to Hadoop. We talked to a lot of customers, and one of the customers told us that and he's a business user, that getting access to a Hadoop cluster in their environment, because each Hadoop cluster sometimes gets used for specific use cases, some are mission critical, is like waiting for the bathroom key in a gas station. It's a long queue for that. So I don't know how many of you agree with that concept, but that there is, and you talk to folks out there, getting access to a Hadoop cluster is really challenging. And that's something that if you don't give access to your data scientists to be able to get quick access to a cluster, do fail-fast experimentation, you're not going to drive the adoption. Because if you don't have access, you're not going to learn, you're not going to be able to try different things out. So fundamentally, the concept of self-service, right, which has proven, whether it's enterprise software companies that have moved to a SaaS model or any other type of software company out there, once you enable self-service, that has proven to simplify the software as well as drive usage. So that's kind of, I think, the importance of self-service. So let's take another example here. If you're a business user or data analyst, how do you work today? You have an analytics or a visualization idea. You open up your BI tool on your desktop, just using it as an example, whether it's Excel or Tableau or even just a BI tool that is delivered in a software as a service model. You point to your data. In the on-premises context, you may point to a file that's on your laptop. You may point to a file that's on an NFS share, or do an ODBC to your database, provided you have the credentials, and you're on your way. You start to do analysis that way. And if you can't do that, then you copy all the data into your local system and start doing analysis. That's how users want to work today. They have ideas at all times. They want to get the tool, and they want to get started. So self-service Hadoop. So this is self-service Hadoop defined, right? What we mean by self-service is when big data analysts, analysts working with big data have an idea, and ideas are the whole point of big data is to have an idea about combining different data sets and getting business value, doing some very unique things that are being done by the data science community. Those are all happening all the time. And those ideas are fresh. They decay very quickly if you don't act on them. Then you've got to be able to get in the world of big data, the cluster is the computer, right? So you have to be able to provision your big data computer, which is a Hadoop cluster, with the necessary applications. I'm going to take example of Hive or Pig, which are the most popular tools out there, or even a BI tool. You want to be able to get that tool quickly because that's the only way you're going to be able to operate on a lot of data. And then point to wherever the data might reside, right? So you might have data in an existing data lake. Somebody built a data lake and there's data there. But then you also found that there's some data, especially in the enterprise context, you might have data in an NFS file system. And you want to see whether you can combine those two data sets. So you want to be able to point to that data, much like what you do with your BI tools today. And Tableau is an example. It has fundamentally changed the consumption model for BI. Similarly, if you have this kind of a concept where I'm a user, I don't have to talk to an administrator, I can get my cluster, get my BI tool, in a few clicks, point to my data and run my Hive or MapReduce job, that's how you're going to drive adoption. And that's what we mean by self-service. And we'll show you this as we walk through it in this presentation. So some of the use cases here are ad hoc exploration. For example, can I blend this data in my data lake with the data that I just found? It's existing in a file system somewhere. And before I move it and request for it to come into the data lake, can I go try to blend that data? Can I do some experimentation? You don't know what you don't know. You want to try working on some data set. You want to explore it. You want to run some jobs on it, do some statistical sort of counts on it, what have you. So doing that experimentation. And if you're a true data scientist who runs with predictive learning models, you want to get a dedicated sandbox. You don't know, upfront whether your job will crash the cluster or not, so you need to get a sandbox environment. And then bursty workload. You always have these end of quarter drills where your manager wants you to go run a job, get some insights, and you want to do it quickly. So you want to be able to act in minutes or hours, not in weeks or months, which is what happens today. That's why self-service Hadoop doesn't exist on-premises. So, the state of the union right now in the on-premises context, and we've talked to many customers, is if you have an idea, you have to first see if you've got a Hadoop cluster or not, because if you want to use some of the compute engines that are provided by Hadoop. And then if you've got a cluster, you've got to check whether the data is available or not, because you've got to move all that data into that HDFS file system. And then if you've got that, then you've got to figure out, okay, I'm going to submit this query, I'm going to do this machine learning job, you're going to have some code review. You're not going to be allowed to just go run your job on a Hadoop cluster that is maybe running some other jobs or supporting some specific use case. So what that means is that there's a lot of lost business opportunity and a lot of insights that you could have gained that you're losing. So we want to enable, self-service enables from idea to infrastructure to insights in minutes versus what happens today, which is just getting to the infrastructure takes weeks. So I wanted to quickly chat a little bit about what are the key building blocks of self-service Hadoop. Look, I've emphasized a lot of time on self-service and the value for the business user. So we talked about that, right? There are 4 ingredients. One is easy access. So think of Amazon again, a web form where you can go in and you can say, I want a Hadoop cluster with 15 nodes, and I want a few BI tools provisioned with it, so I can go do my visualization or analytics. So easy access, just being able to have an idea, log into your computer, get to a web page, get your cluster. And then having elasticity, because when you go run a job, initially you might just do some exploration. You might just look at some data sets that might not be very compute intensive. You might originally start with one simple data set that might be in your existing, in your data lake or in your local file system. But then progressively, your analytics cycles, analytics is iterative, you're going to start to increase and add more data sets. You're going to increase the complexity of your compute jobs. So at that point, you'll need elasticity. You'll need to be able to expand that cluster. And that's where the concept of using virtual machines or Docker containers is extremely useful, right? Because provisioning a physical server, you're not going to get elasticity with that. But using some software-defined infrastructure like a Docker container or a virtual machine is critical. The third one is applications. Initially, your use case might be, I'm browsing data, I'm doing some counts on it. Next use case might be you want to add, you want to stream data, some log data, and do some searching on it. So you might add new services, so new applications may be needed. So in the concept of self-service, you don't want to start and say, okay, give me the whole Hadoop stack, every single service. You might want to start progressively. You'll say, okay, I need MapReduce and Pig and Hive. That's good enough for me right now with the Hue console. Okay, now I want Storm. Now I want some other application. So being able to access those applications quickly. And then last but not the least, having access to the different data sources. So being able to take your Hadoop cluster, which is your computer as I mentioned earlier, and then being able to point to an existing HDFS or to NFS, being able to point. Those are all aspects of self-service. But again, we all know, I mean, many of you are on the operations side, business users have a habit of kicking themselves and in their feet and stamping over each other sometimes and falling over. They run a job and it fails. There's an exception. So you have to, how do you support them, right? So day 2, if the user has a problem, you need to be able to support those users. That's how you're going to increase adoption. So if it could be something as simple as not enough memory available. Users run queries. That's their end users run queries. They want to try different things out. They're going to trip over themselves. So then you need to be able to have the operational oversight so that when they trip over themselves and make a call for administrative support, you have all the tools and applications to troubleshoot and monitor and get the logs, or if you have to call the vendor, you have the right tools and the right applications. And that's kind of on the right-hand side, right? So you need a handshake between the end user experience and the agility and the administrative oversight from an Hadoop administrator. So that's kind of one of the areas where Apache Ambari fits in. And this is what I'm going to drill in a little bit more in this talk. So why Apache Ambari? So on one hand, for self-service, we do want to create a simplified user experience. So you want to create an experience which is like a simple web form to deploy a Hadoop cluster. So using Ambari's RESTful APIs, it provides a very powerful framework with the concept of stacks and blueprints and views. You can create your own purpose-built experience for the end user and then power it with Ambari RESTful APIs to create that Hadoop cluster. With the RESTful APIs, you can have granular control on the deployment of services. So like I mentioned, when you are a business user and you want to start with the cluster, you don't want everything. So you only want to deploy those compute services that are requested by the user initially, and then add additional services as needed. So that actually has 2 benefits. One is obviously it's more lightweight. But the second key benefit in the concept of self-service is you don't want to wait for hours. You want to be able to get your cluster as quickly as possible, in minutes ideally. And the third one is enterprise-grade security management and monitoring capabilities. So this is something I talked about earlier, which is being able to provision a console, which may not be used by the business user or very minimally by the business user, but is available in that cluster so that a big data admin, a Hadoop admin can come in and respond to those support calls from that user. So this is kind of one of the most powerful things about Apache Ambari is that it is an extensible framework. I'm sure many of you use it for deploying your Hadoop clusters, but perhaps more important in its capabilities is this RESTful API, so you can tailor the user experience for your end users. So how are we doing, how are we delivering on this self-service vision and value proposition, right? So the way Blue Data works, and you can try to build this yourself, but we've got a product that we spent some time and productized it. But I think the concepts that I've talked about, you can obviously use other infrastructure and try to build it. But we've done this in the following manner. You take physical servers and you take our Blue Data software, no Hadoop yet, but what we create at that point is a virtualized infrastructure that basically spins up big data VMs or big data containers. What do I mean by big data VMs and containers? We basically have images that have all of the software bits. So for example, HTTP 2.2, the Ambari server, the Ambari agent. And we have images of various Hortonworks distributions, as well as other distributions from other vendors, as well as Spark standalone. So we have these images. And they have all of the software like Java, Python, the client software, and so on. So we package those into images. So make it easy when you spin up big data VMs or containers, they have all the software bits. So it improves the speed. The second one is we've thought through a self-service user interface that in addition to providing that simple form to create a provision a cluster, which then uses the Ambari APIs behind the scenes. But we also have a user management and a policy engine to apportion resources, compute and memory resources that are pooled from the physical servers into quotas. for different tenants, like lines of business and so on. And then we use Apache Ambari to orchestrate the deployment of Hadoop on these big data VMs or containers. So you can get virtualized Hortonworks Hadoop clusters, and then we use the Ambari APIs to expand that cluster if the user requests additional nodes. And I'll show you a few screenshots and a demo as well. But perhaps more important for the administrators and the operations folks is we also provision the Ambari console. So while the end user may not necessarily go into it all the time, you have access to the Ambari console unmodified, so you can go and do all of your traditional troubleshooting jobs. And as far as the virtual clusters are concerned, we also provision, we use the Ambari APIs to pinpoint and in a granular fashion provision the compute services. So just a few screenshots. I'll give you a live demo of the self-service experience because I think that's most important. But this is the kind of form I'm talking about. Like a business user comes in and says, I want a cluster. Choose the cluster type, Hadoop, HBase, what have you. Choose Hadoop. Choose HTTP 2.2 with Ambari or HTTP 2.0. Choose the MapReduce type. Choose the flavor, of the virtual machine or the container, and the number of workers, and click, and then choose the specific services, the most common services, and click submit. Literally 5 clicks, and you get a Hadoop cluster getting provisioned in minutes. That's what I mean by self-service. So you're not exposing them to the complexity of another user interface. And then once the cluster is provisioned, you get something that looks exactly like a physical cluster. A bunch of virtual machines that have IP addresses, so you can SSH into them if you need to. A typical business user wouldn't need to. We do provision the Ambari console right there, so there's a link, and we'll show you in the demo. And then you have the Hue console, which is the UI for Hadoop, right? And you can then start pointing to data, and the various compute services like Node Manager, Resource Manager, etc. And then you have the full Ambari user console that so many of you are used to. You can go add new services and so on. So how are we doing this, right? So just a double click on the details. We have 3 phases. The first phase is once that user interface is used by an end user to submit a request, we provision the VMs based on the number of VMs that were requested. And those VMs are pre-deployed with the HTTP 2.2 bits and the Ambari server and the agent components. Those are pre-deployed. And then we remove some dependencies around HDFS. I'll talk to that in a little bit more detail on why we do that. And then we deploy the core stack. And so in this phase of the deployment, behind the scenes, again, transparently, the agents register with the server, and then we make point REST API calls to deploy the stack. And we modify the core side XML because we have an HDFS abstraction layer, which I forgot to mention in my previous slide, but we're deploying the compute services only because one of the value propositions we have, you don't have to do that, is that you can connect to multiple data sources. So we add in the blue data abstraction layer. Much like you have S3:// we have something equivalent to that. And then we shut down the HDFS service. And then phase 3 is we basically go in and in a granular way start up all of the compute services. So our design is optimized for cluster creation speed and user feedback because as each service gets added, we want to make sure that it succeeds. If it hasn't succeeded, we want to give a feedback to the user so they can try again or they can get help. We want it to be, again, fail fast. So this is a little bit of a loaded slide, but just to give you an example of how one specific service might be loaded. So on the top part, you're seeing a service like Pig that's being deployed by us. And then we're using the RESTful APIs, and that's the most important part here is the fact that Apache Ambari provides you granular control through their REST APIs. So you can deploy this specify which service you want to deploy, pass in the configurations, and then do all of the installation and distribution of the different configurations. So just a little bit more on the design choices and considerations. There's a lot of exciting stuff happening in Ambari. We used Ambari 1.7 in this example. We have some plans to already sort of move to 2.0. We are relying on the granular RESTful API calls, as I mentioned earlier. So we're using the REST API calls to orchestrate that. We use blueprints we do use blueprints, but we use in a minimal way. One of the reasons why we went with using the granular RESTful API calls is that once the cluster is created and the stack is deployed, we wanted to have better control on which individual services are deployed. So today, if you use a blueprint and the user wants 4 services, we basically have no way to get feedback after each service is deployed, or we haven't figured it out, one of those two. But I think that's we've looked at it very carefully, so we wanted to do that. But you can use blueprints. There is a way to deploy a whole set of services in one swoop. And lastly, we used individual REST API calls with static configuration files. This is something that we want to work on. We would like to leverage the Stack Advisor functionality that is available in Apache Ambari. It's a very useful functionality. It's able to kind of allow you to get best practice configurations based on your specific deployment of Hadoop. So what I wanted to do right now is give you a short demonstration of this self-service experience. So if you could, thank you. All right, fantastic. Okay. So this is the user interface that we have with Blue Data. So once you deploy the Blue Data software on the set of physical servers, we provide a role-based portal, which incidentally is also, all of this user interface is fronted by RESTful APIs. So I'm going to log in as admin just to show you the top-level user interface. So this is the we provide that cloud-like experience. So we have the notion of tenants. And you can get a more detailed demo at our booth. But in this case, we have a tenant, and we have basically 2 tenants. But what I wanted to show you in the context of the Ambari is that we have these images. These can be Docker images. These can be VM images of various versions of Hortonworks, right? So HTTP 2.2 with Ambari, 1.3, 2.0, 2.1, as well as some other images that we have there. So these are the images that are used by an end user or presented to an end user. So let me log in as an end user, Mary. So she's a data scientist, just had an idea and wants to experiment with some data that she just heard is available in the NFS system. There's also some data in their data lake. She wants to be able to combine those two. And she wants to do it in a self-service manner. So when Mary logs into Blue Data, she gets to, gets a front page just to see how much of the resources that were allocated to her tenant have been used by her tenant. So in this case, she has about 96 cores and 44 gigs of RAM. She can go in and look at the data tabs. So this is where you can create connections to various data sources. So in this case, she has data configured to NFS a file system, as well as to a data lake, which is essentially an HDFS, Kerberos protected HDFS data store. And she can add any number of data tabs because she has the permissions to do that. So this is where she's pointing to different data sources. And there's already a cluster here, but she wants to go ahead and create a cluster. So she can go in, and it's made extremely simple for her. So she can say, I want to create my Hadoop with Ambari, choose the type of cluster, choose HTTP 2.2 with Ambari, and choose some virtual cluster nodes, choose the specific application she wants, and click submit. The whole idea here is that there's not enough resources, so we're just going to go with 2, right? So she has a quota on her limit, but she can go and ask for additional quota from the administrator. So that's kind of starting up right now. So while that's starting up, let me kind of look at the existing cluster. So this one also was an HTTP 2.2 with Ambari that was provisioned by the user. And when it was provisioned, it essentially created a virtual cluster that kind of looks like a physical cluster. It's got IP addresses. the Ambari console was provisioned, and all of the different services, all of the compute services. Now you can click into Ambari and log in. She can put a username, password in there, but she can see all the different services. So this is standard Ambari running on the virtual machine. And at this point, if she wanted a specific service that she didn't have already, she could go ahead and add it from Ambari. Or she could, or if she had a problem, let's say she was running a Hive query and there was a problem with heap size or memory size, she can call her administrator who can log into this interface, go into Hive, look at the different configurations, and perhaps go ahead and increase the heap size for Hive to something larger, and then save it. Right. So, I don't want to give you a full demo of Ambari functionality, but it is a fairly rich interface. It has version control for configurations. It's the kind of tool that a Hadoop administrator would want to use. And it's the kind of tool that you will have all of the fine-grained access, and you'll be able to harness all the innovations that are coming in Ambari. Now let's actually go into the self-service experience that I talked about, right? So now as a user, I'm going to use Hue console. We also can provision BI ETL tools like Platfora, Datamere, and so on in virtual machines right adjacent to this cluster. But in this case, I'll use Hue. So she's familiar with SQL, and she knows where her data is. I showed you the NFS data tab. I showed you the HDFS data tab. She can now go into her Hive console in Hue, and I've pre-created some queries just so that I don't have to sit and type here. I've got a couple of tables here. So one of them is NFS data. So she's got a file in NFS. So now she can create a table pointed against her NFS data. And it's exactly the same as Hadoop, except now instead of HDFS : / you're pointing to your data tab. That's a HDFS abstraction that Blue Data provides. It's dtab : / NFS _ data, and there's a file that's out there. Okay. Similarly, she has a data in her data lake, and that is in her tenant storage. It's called tenant storage, and it's a product file, and she's created an external table against that. Normally, if you think about this, if you wanted to do this, you would basically have to go to your NFS and copy all that data into your local HDFS cluster, right? So that's typical model, but here you're able to take from your Hadoop cluster, point to these two different data sources, and then she's going to go ahead and join these two data sets. She doesn't know whether there's value in it or not, but she wants to see if there could be some insights if she could get if you join these two data sets. So now, at this point, she can go in and execute this query. And you will see here that this is pointed to external NFS, and it's pointed to HDFS, and this will kick off the job. And it is, standard map reduce. It's going to spawn. I'm not going to give you a tutorial on Hive. It's going to start off the map reduce. But the key thing here is exactly the model that I talked about in the beginning of the presentation. Mary had an idea. She logged into her interface, created a cluster, her big data computer, pointed to her data sets, did not have to move all of that data. That file out there could be hundreds of gigs, could be terabytes. She could now run these jobs, and the data is streamed to the cluster at runtime. And the job is on its way. So with that, that's the demo for now. Hopefully this gave you a better sense for what we mean by self-service and what we mean by the whole concept of going from provisioning to running a job from remote data sources. So with that, I know I have about 5 minutes or so left. I wanted to open the floor for questions. I also have some of my colleagues from Blue Data here, so we can answer any question that you might have, whether it's technical or business user specific. Could you use the microphone, please?
How do you configure the different properties, like let's say yarn, some properties? So what's the UI or user interface do you have to do that? And where do you manage the configurations to?
Yeah, so first things first, when we deploy the cluster with Yarn, we use the best practice configuration, so that's the static configurations. But then post-configuration, as I showed you in the Ambari console, so if you're an administrator who was called up by the user to say, hey, my jobs are running slowly or I'm getting these exceptions, you can log into this interface, open up Ambari, and go into the Ambari configuration and change all of those parameters that you just talked about. So like Yarn configuration parameters can be changed through the Ambari interface. So does that answer your question?
So where do you keep the configurations? Is it change it directly on the cluster, or do you want to keep it separately so that in a reusable way you can submit new data?
Oh, I see. So can you go to the stage? Can you take the microphone, Ajay, and answer the question?
This is Ajay from Blue Data. I worked on the Ambari stuff. So if you, when you give the configurations, you can give the configurations as a JSON file to Ambari server, and Ambari will save that in its database, in its Postgres database. So yeah, that's how. So whenever you those configurations are saved, and then when Ambari provisions those services, it will provision them as XML files on whichever virtual machines you have, and those configurations will be used. And if you want to change the configurations, you will have to talk to Ambari. Okay, these are the configs that I'm trying to change. You give it a JSON file with the change configs. It will save the configurations and then load them on the virtual machines.
Just give to him.
So did you guys try deploying Cloudera's distribution via Ambari? Like, I want to deploy Cloudera's distribution via Ambari because CDH Manager is not open source and all that stuff. So
No, we haven't done that.
okay. Can the Ambari support tarball-based installation instead of RPM-based installation? Like right now it is RPM-based, right, completely.
So it uses RPM based. So you, right now Ambari has like a list of services, distributions you can install. But if you want to add your own, it gives you a method to add your own service to Ambari. So there's a way to do it, but it's a learning process.
But one of the things that we want to change is, though, you don't have to worry about RPM and tarball and so on. So we're giving you these images so that it's easy to deploy Hadoop. And that's kind of our mission here. 1 second, there was a question here. Can you come up to this podium and ask the question?
My company is using Platform BI tool. Whenever we build out a Hadoop cluster, we have to build a Platform cluster as well to connect to that. So how well does Blue Data support installing a complex product like Platform? Does it have customization abilities?
Yeah, actually, you should definitely visit our booth. We support Platfora.
Okay.
We're partners with them. You can provision a utility VM cluster, which is just with the big data VMs, a cluster of 4 or 5 machines.
Okay.
Deploy your application of choice. If it's a clustered product like Platfora, you could deploy that, snapshot it, and register it back in our catalog. So other users can go to that same self-service screen, and when they choose the specific distribution and combination like Yarn and CDH 5.2, the Platfora image will show up as an option. So we can deploy a cluster along with a Hadoop cluster, a Platfora cluster along with a Hadoop cluster.
So you just said snapshotting a VM. If I was able to build out a Platform cluster that's highly customized in my company, could I snapshot that VM and then put
Yes.
that in back into the Blue Data repository?
That's right. That's our key value proposition. Infrastructure software, so that's what you can do with us.
Thank you.
Can you come up to this?
My question is, well, I actually have 2 questions. Question 1, could you help elaborate more about your base image you are using? What do you put in your base image, the image to spin up the VM? Question 2 is, how do you deploy the Hive into your cluster in a self-service way, I mean automation way? Because I think Ambari doesn't support Hive right now.
Yeah, so our base VM image is based on CentOS 6.4, the operating system in the image. With the Docker container image, it can obviously inherit from the base operating system. In terms of the Hive console question, so is that the question for, yeah, so we're using CentOS 6.4 in the image.
VM snapshot image, we install Ambari. But then Ambari can access, we give it a repo. You can point that repo to either public, but right now we have a local repo inside the VM image. So it will go to local VM repo and install the services. And so all the services that you install that Ambari supports, you can show, that will show up in the Ambari UI. But if there are services like Hue, which Ambari doesn't support, you can still have them in the VM image. You can start them using using your guest configuration script, which the Blue Data management software will start those services on the VM. So that's how the Hue came up. Hue is not officially supported, not supported in the list of applications, but you can put the Hue in the VM image and then start them. So Ambari 1.7 doesn't support loading, like rolling upgrades, but Ambari 2.0 supports rolling upgrades. So if you want to upgrade your cluster, running cluster dynamically, then you Ambari 2.0 when you are planning to roll out upgrades.
So the other concept here, as you saw, which I didn't highlight, is that we're spinning up compute-only clusters. So you can just like delete that cluster and get a new version up and point to the data. So that's another important concept to keep in mind with this kind of an approach. But yeah, with Ambari 2.0, I think there'll be more features that will be added, so you can upgrade this persistent cluster. Can you come? Yeah. Yeah, so the data can be it can be resident in the NFS. It can be resident. NFS is an option. You can just use our product against HDFS file system as well. Or you can, like I showed in the demo, you can take some data in NFS, take some data in HDFS and combine them. Run a MapReduce job against both of them. We are keeping the data outside. Data is data. We stream the data in at the time of running the MapReduce job, much like in a physical cluster when you go through the HDFS client and run a job, it's getting the data from the different data nodes via the name node. That's exactly what we're doing. We have a HDFS abstraction layer. So you have the ability to specify where you want to write the output data. So you can write it back to NFS, you can write it back to your data lake, or you can write it back to the disks that we have on the physical servers in our Blue Data system. Yes. We are separating compute and storage, and we are relying on fast networks to move the data to the clusters. That's the only way, by the way, to be able to really get self-service. Self-service is not just clusters, you got to be able to access data.
What other features in Ambari would you want? Or what's the next thing that is going to facilitate the process even more? Oh, I'm an Ambari PMC, so I'm interested in knowing what's good development work for us.
So one of the things that we were think was while working with Stack Advisor, we would want Stack Advisor expose an API to be able to talk to Stack Advisor in terms of what all features it has. So I think right now there are some part of configuration is stored in the JSON files and how you specify the JSON files to control. But the other things that not in the JSON file, it will be good to have an API with Stack Advisor exposes for that configuration.
Guys, I encourage you to come and talk to us after the session. We're waiting for the next session. So really appreciate all your questions and your participation. Thank you for your time.